Hello and welcome to this lesson video where we'll continue learning about machine power after we learned about the total resistance or required power from the previous video. This video covers the shown two learning objectives. This video is a second part of the machine power lesson. We continue our distinction here between required power, available power, and usable power. Each equipment has available power for use in its whole travel, which is delivered from equipment engine to the torque converter, transmission, and finally to the wheels or the drawbar if the equipment is track mounted. Almost every equipment has diesel engines as they are more efficient and cost effective than gasoline ones over the life cycle of the equipment. The available power initially delivered by the engine is measured in flywheel horsepower, which is standard measurement for unit for machine power. As you can see, available power is dependent on the equipment and its mechanical system efficiency. But we need to know how much of it can be usable by the equipment to overcome the total resistance, meaning grade and rolling resistance. This is why we'll focus next on usable power, which is dependent on the available power, which we will give it a name Rimbaud, and the soil traction with the wheel. Rimbaud is the power or force that's available at the contact point between the wheel, tire, and the ground. For the same force in crawler track mounted equipment, we'll use the term drawbar pull. The Rimbaud force in kilogram can be calculated using the shown formula, which reflects the fundamental engine power-speed relationship. The Rimbaud force is dependent on the engine horsepower, or the available power, the engine efficiency, and the equipment speed in kilometer per hour. It's clear that greater Rimbaud can be achieved by an equipment with higher horsepower and efficiency. It's interesting to note here and the inverse relationship between the Rimbaud or power and speed for the same engine output and efficiency. To achieve higher Rimbaud, the equipment will have to drive at lower speed. If you are a fan of manual cars, you must have seen this inverse relationship in action when you drive on a steep uphill road, and you will have to use a lower gear and drive at slow speed. You can see on the uphill highways where shipping trucks drive very slow in the right lane to be able to pull their loaded weight. To calculate Rimbaud in pound, here is a revised formula with the speed now in miles per hour. Same relationship, but different formula, constant in units. Beside Rimbaud, the usable power is dependent on the traction capacity between the equipment wheels and the driving surface. The Rimbaud will be fully usable if the traction is sufficient, will not cause the wheel to slip. Even if you have the most sufficient equipment with the strongest engine, driving on a slipper road with lower traction will limit you on how much power you can use to move a load. To estimate the traction force, we need to cover the coefficient of traction. The traction force is calculated by multiplying the coefficient of traction by the weight on the powered gear or the wheel axle. The coefficient of traction is dependent on the surface condition and the equipment type, being wheeled or track mounted. The coefficient of traction value can range between 0 to 1, where 0 means no traction and 1 means full traction. This table from the textbook shows the suggested coefficient of traction values for the wheeled and crawler track-mounted equipment on different surface types. Of course, the lowest traction exists on ice. This is why we have more road accidents in the winter. For wheeled equipment with tires, the best traction is achieved on dry, rough concrete, and then it decreases when the surface gets wet and loose. For crawler equipment, it is better to use it on a rough, dry soil surface, not concrete. Regardless of the traction, it is not recommended to use crawler equipment on hard surfaces like asphalt or concrete, as cracks will damage the surface over the time. The weight on the powered wheel depends on the equipment type. This is why four-wheel cars are better than front or rear wheel drive cars, because 100% of the weight is applied at the traction between the powered wheels and the traction and the soil. The percentage of the equipment weight to be used for traction calculations is provided in the equipment manual or specifications. For track-mounted equipment, we don't have wheels, so 100% of the weight is applied in the coefficient of traction calculation. So in summary, the usable force will equal the minimum of the equipment rim pull, available wheel power, and the traction force. Please refer to the exercise video of this lesson to see example calculations of rim pull, traction force, and usable power. In the next lesson, we'll learn about performance charts as an easier graphical way to deal with the machine power and identify the travel speed of the equipment under specific load and surface conditions. Thanks for watching. Take care.